Hey guys, so here what we're going to explore is we're going to kind of think about another look to the same idea of what is an equivalent fraction. So, as we explore that, what we're going to want to think about is well, what is an equivalent fraction again? Well, an equivalent fraction is when one fraction is exactly the same value as another, but it just has a different look. It has a different numerator and denominator. The numerator is the top number, the denominator is the bottom. So, as you look at this sort of rendition or this way of looking at what is an equivalent fraction, this time we're starting with these pies, right, or these circles. And you're going to want to think about finding a similar wheel or pie or whatever circular, formation you like to think in. And you're going to want to find one that is the same value. So first things first, though, I want to know, well, what is the value if we work with this orange pie up here? What is the value? What is the fraction of this pie? And the way we do that is we count up how many are shaded in. One, two, three, four, five. So we have five orange pieces. So that becomes our numerator, right? And then what the denominator is, what it's representing is the total amount of pieces that there are. So we say, well, five are orange plus one more, white one is six. So our fraction, our original fraction is 5/6. What we want to do now is we want to find a fraction that is equivalent to that, but has a different look, is chopped into a different size piece, right? So instead of having six pieces, we want there to be something else. So we might say, well, I know that one multiple of six, if I double it, becomes 12. So let's see if there happens to be one of these pies down here that has 12 pieces, because I know I could easily chop up each of these six pieces in half to make double the pieces. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. That wouldn't be easy, right, to really chop them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, this one has 12 pieces in it. So I'm going to go and delete these little blue parts and we'll say, okay, well, let's try that one. So if we move that up here, oh, the blue things came back. Just really like being on there. We're going to delete those. So as we look here at this size pie, I might just stretch it to be a little bigger so it's easier for me to kind of analyze. Well, what I want to know is now we've chopped our six pieces into 12. 12. So our denominator has changed, right? The total amount of pieces has changed. But what we want to do now is figure out how many of them do we need to shade in orange to be equivalent to this one right here, right? To have the same amount of pieces or same portion of the pie shaded with a different amount of pieces. So what we might do is think, okay, well, if we have five pieces right here, and so that's represented here, I might think about chopping each of these up. One, two, three, four, five. Okay, so in a perfect world, those are perfectly cut in half. We're just going to pretend because obviously they're not perfect, but we can imagine, right? And say, okay, well, when I chop them in half, I've doubled. So one, two, three, four, five, six, seven, eight, nine, 10. So what was five pieces now becomes 10 pieces shaded in. One, two, three, four, five, six, seven, eight, nine, 10. So all of this gets to be shaded in. Oops, and I should have probably done orange, but we're just going to go with blue. It's turned into a blueberry pie instead of a pumpkin, perhaps. So now we have a numerator of 10, same exact amount of pie, right? It can be kind of handed out, but now you can double the amount of people that you give it to, okay? So what you can do as you kind of explore the rest of these is you can think about, what do I know about the fraction I have, and what can I do to change the amount of pieces, to change the denominator first, and then think about chopping up those pieces to also then change the numerator.